Assalamu alaikum warahmatullahi wabarakatuh. This is Ahmed Higazi from SEG CAD Solutions. Today, inshallah, we will present the ability of SEG Software to create the storage tanks with a fixed roof, and we will discuss some points regarding to the elements that we can create it and how we can make the 3D model and create the detailed drawings for a storage tank. Okay, let's at the beginning discuss the elements that we have the ability to add it in this model. Let us define it in two types. The first type is the main elements like annular plates, bottom plates, shell plates, and compression ring and roof. Those are the main elements of the storage tank. And the others shall be the accessories like the anchor chair, manways, clean outdoors, spiral stairs, and we will discuss how we can add those elements in our model. At the beginning, let's define the types of annular plates. In annular plates, we have three different types. The first type is annular plate with equal pieces. In this type, you have the ability to define the number of annular plates, and they will be, all of them are identical. The same arc length, the same thickness, the same width, all dimensions shall be the same. The second one, which is the annular plate from different pieces. In this time, you have the ability to define the arc length for each annular plate, but the thickness will be the same for all. The third type, which is annular plate from different pieces and thicknesses. In this type, you have the ability to make both of arc length and the thickness differ from one to another. So the main difference between the three types here, which is the controlling on the arc length parameter and the thickness parameter. The second main element, which is the bottom plate, we have in SEG software four different types of bottom plates. The first type, which is radial bottom. In this type, you can create radial plates to create the bottom plates, and the second type, which is sloped bottom with arranged plates to inside or to outside. That is the third type. The last type, which is flat bottom with arranged plates, and the last three types, you can use a new tool in SEG software to make the arrangement of plates of the bottom. The shell plates. In shell plates, we have in SEG software more than 10 different types of shell plates, but actually we will use two types only in storage tanks. The first type, which is shell from different pieces. In this type, the user will define the length of each plate. But let's say in the beginning, the SEG software will make all of them are equal and will give you the ability to change the required piece length as a user defined. And in the second type, which is shell from different pieces and thicknesses, in this option, the customer will have the ability to define the thickness of each plate and the same for the arc length for each plate on the shell course. And we will discuss that in detail in our demo. In the compression ring, you can figure that we have different types of compression rings according to the API, so you will select the suitable shape and change the dimensions according to your design. Roof plates. In roof plates, we have three different types of roofs. All of them are fixed. The first type is radial roof. The plates will be radial to the center of the tank. The second type, which is arranged roof from plates, okay, like the bottom. The third type, which is dome roof, and you can make this roof as a dome roof. In the image on the middle of this slide, which is the torch cutting tolerance, this option you can use it to calculate the cut tolerance on the blade, and this will be used on the nesting. This value is very important in nesting, because in nesting you will make a cut between elements and between elements, so you should define this value actually like in your site. Now we will discuss some accessories or attachments to the tank, like the anchor chair. In the anchor chair you can add a rear plate to the anchor chair, and you have the ability to remove it if you don't want it. You have the ability to add it. And regarding to the required number of the anchor chairs, you can define the quantity of the anchor chairs to make them as a better. And if you want to make them separate, like defined one differ from the others, or one of them have a rear plate, or one of them on different shell thickness, so you have the ability to define them separately, and you will not use the pattern option. For the clean outdoor, you can make the clean outdoor according to the API requirements, and you will figure that you have 3 different types of davit, so you can select the suitable shape from davit to this clean outdoor. It depends on your requirements and the size of this clean outdoor. The same form and way. Here for the spiral stairs, you have the ability to add a spiral stair to your storage tank, and you can add any number of levels of spiral stairs to your model. For nozzles, you have 2 different types of nozzles: the API nozzles, or nozzles according to the API requirements, and the nozzles according to SME requirements. You can change the shape of the configuration of the rebad according to the API requirements. If it was a circular or diamond rebad, or circular low type or diamond low type, so you have the ability to change this. And in SEG software, there is a tool for the blade arrangement. We will discuss it in detail in our model during our presentation, inshallah, and show the options available in this module. And finally, we will make some nesting studies during our presentation. Okay, now let's start our model. From here we will open SEG software. After opening SEG software, from new tab we will define our project name, and select the location on the hard drive, and from here we will select tank module and click finish. From the tree right here we will select the equipment and rename it TT100, and after selecting it again, and from setting we will select equipment setting, and you can figure that the position is changed automatically to be vertical and bottom to top. That depends on the type of the project. It's a storage tank, so those values shall be changed automatically. Here we will define the delivered blade dimensions, and those shall be used in the calculation of the blade arrangement for roof and bottom and shell plates. So let's define the required or the delivered blade dimensions, and from here the surface and the serial number, and you can define the material from here. Okay, from app setting we will make a preview for the parent and the child, and the sort numbering to make it sort numbering, and click save. Okay, now we will create the elements, and from annular plate we will select annular plate from here and click add, and from here you can figure that those are the 3 types that we discuss them from minutes. And from here we will define the inside diameter of the storage tank, 22.5 meters. The first shell course is 14 millimeters, the annular plate thickness, and the projection 75, and the edge, let's make it 1100, and here the bottom thickness, let's make it 10 millimeters, and the longitudinal building line orientation, let's make it 20, and the number of the required annular plates 18, and click save. Now we will click assembly to start the assembly. Let's come back to Autodesk Inventor. Okay, now we will make a nesting for those plates. Let's select one of them because they are equal, and let's make a nesting for it. So we will create a nesting study, and from here we will select standard nesting. Detecting the material and thickness of this item. After importing, we will click OK, and from process here, if we select this one, you have the ability to define the length and width of the plate shall be delivered. And from nesting, we will create a new nesting here, and from here we will define the required number of this plate and update this nesting again. Okay, you can figure that the efficiency of this nesting is 54, and 3 plates inside the annular plate, and we will need 3 pieces only, so we will need 6 sheets to make those items. Let's make a small modification and check that what will we do, what will be changed on the model. Let's make the length to 1 meter, and the required number is 16, and click save, and let's click start and check the model again. Okay, here we will make a nesting for this plate and repeat this process again. Click yes, and after extracting process, we will click OK, and from here you can check the dimensions of nesting plates, and let's create a new nesting. And from nesting, right here we will define the required number, which is 16, and click OK. And right here you can figure that we will need 4 sheets only after this modification, and the efficiency is increased to 75%. Okay, now let's add the bottom plates. Now we will come back here and add the bottom plates, and from elements we will select the equipment, and from here we will select a rigid sloped bottom. Click enter, and from here we will select the type of the bottom, sloped to inside or outside. Okay, and from here we will define the bottom thickness, the overlap, and the inside diameter of the tank, of the inside diameter or the outside diameter of the bottom, the material of the bottom, the slope, and the cut tolerance. And from here we will click save and open this model. This slide is controlling the size of this circle right here. So if you make it like this, it will be small. If you make it like this, for example, and update, it will be like that. Now we will make some studies, and we have some options to make the plate arrangement. So from here, let's select mid row and click row plates, and by selecting this checkbox you have the ability to add a mid row right here. But if you take a look, we have a small pieces right here and we don't need it. So let's check another option, which is make all of them are centered, and click row, and you can figure that this is better than the other one. And let's select the set grid and make a reverse and select row, and you can figure that we have small pieces right here. So let's make it mid row and all centered, and click draw plates, and this option is better. Now let's change the orientation of the building lines here and click save. Now we will go to the assembly and click start assembly. Now let's add a shell course. From here we will select the vessel or the equipment, and let's add a shell can 1, and in this type we will select the shell from different pieces and thicknesses. Why we select this type? Because we have a clean out door, and this clean out door will be on a different shell course with a different thickness. So let's select OK and define the inside diameter of the tank, the height, the main shell plate course, and the number of plates, and let's click update. And now we will define the thickness for each plate. Okay, and let's take a look on the last plate with a negative value, and the save button is not active. Here we will define the first plate width or the length with 4 meters, and the fifth plate with 6 meter length, and click update. Now if you take a look to the last plate length, it's 4 meters 0.1, around that number. And from here, if we change the start angle of the first plate, you can figure that the mid angle of the first plate is 10 degrees and the end angle is 20 degrees. So we will make the middle of the first plate on the 0 degrees. So we will make this value with a negative value 0.19, 16, and click update. Now you can figure that the mid angle of the first plate will be on the 0 degree. And let's modify this one as a clean out door and change the thickness of the first plate to be 19 millimeters, and click update and save. And let's click start. After finishing the assembly, you can figure that this plate with a different thickness, if we get the measure tool and measure the length of this plate, it's 10 millimeters, and for that one it's 14, and you can figure that the color of this plate is different from the others. Let's add a clean out door to this one, and from here, from elements, let's select clean out and click add. From here we will select the type of the davit. Let's select this type, select the size, and if you wanted to make a modification to the API standard dimensions, just select user defined and you will have the ability to define those parameters. From here you will define the thickness of the flange, the thickness of the gasket, and the opening direction. Let's click save, and from here we will define the set weld and click save. Now let's click start assembly. Okay, now we have the clean out door of the tank. Okay, like that. And now we will add the anchor chairs, and from here, from elements, we will add the anchor chair. And from here we will define the anchor chair dimension. If you wanted to add a weir plate, just select this checkbox and define the weir plate dimensions. And let's change the rib height. Okay, let's change the rib height, and let's make the orientation to 50 degrees, and we will need 12 pieces, and click start. Okay, now we have those anchorages around the tank, like this. Now we will add a clean outdoor, so from here we'll select the can 1, and from here select a nozzle according to the API, and let's name it as M1. From here we will select it as a nozzle from plate. Let's make it 24 millimeter, and the thickness was 14 millimeters. The longitudinal building line, location 750, the orientation on 65. The projection, let's define it by the calculator, and from here let's make it as a diamond plate, and the thickness of this one as 14 millimeter, and let's click save. From the calculator right here we will open this form and let's insert a flange, and from here we will add a flange according to the API. It's 24 inches, and from here we will define the thickness of this one, and let's make it from 20 millimeters, and let's click save. Now after closing this and trying to define the projection from the vessel center line, and let's click calculate. Now that's the projection of the pipe outside the shell, okay, which is that value. Now we could increase it a little bit and click OK and click save. Now you can figure that that's the projection of the nozzle from the facing of the flange to the center of the tank. And let's click save, and from here let's rename this flange because it takes a random name, and click enter. Now we will add a gasket, so let's select the external connection and click here M1 gasket, click add. And from here we will select the API gasket, select the size, and define the gasket thickness and the material. Now we will add a blind, M1 blind, and click save. From here we will select the API, select the size, and if you wanted to define the thickness manually, let's make it 20 and make this blind as flipped flange. And now let's add M1 grip or hand grip. So from here we will define the length to be 200, and let's add 2 hand grips, and from here let's add M1 stud, and from here we will select it to be 24 millimeters, and the length will be 20 plus 20, which is, and the length of the bolt. And from here we will add a manway, M1 davit for the manway, and let's click add, and from here select the suitable type for your manway, and let's click start assembly. Now the manway is done, and you can figure that those are the tie bolts and the hand grip and the clean outdoor davit or the manway davit, and you have the ability to change the opening orientation direction by changing this check. Now we will add another shell core system, this tank, and from elements we will add a can 2. But this type of can we will make it as a shell from different pieces only, not different pieces and thicknesses. So from here we will select this type and define the inside diameter, the course height, the thickness, the gap, and the required number of elements, the length of the first piece, and the start angle, and let's click update grid, and you can figure that the last piece is calculated automatically according the above formation. And from here let's add another can 3. Okay, let's make it looks like can 2, but we will change the thickness and the orientation. From here we will change the thickness to be 10 millimeters, and let's make the start angle to be 15 degrees, and let's click update and click save. Now we will add another can 4. Let's make it looks like can 2 but with a different thickness. Let's make it 8 millimeters. Click update, and another more can 5, and let's make it looks like can 3 but with a different thickness, and let's click save, but we need to update first, and click save. Now we will add a compression ring. So from here we will add a compression ring, and for this one we will select the suitable type of the compression ring, and let's define the inside diameter, which is the shell outside diameter at the last course, and that's the offset, the size of the angle, and let's click save. And let's add the roof here. So we will add a hinged roof, and let's click add. Define the inside diameter of the roof thickness, and the roof slope 1/4, the overlap, and the inside diameter or the diameter of the tank at over the angle or the compression ring. Okay, and that's the thickness, the torch cut tolerance. Let's click save and open this one. From here let's select the initial condition as a mid-row, and let's check this option. Here we have very small pieces at the ends, but at the middle it's okay. Let's try this one. Yes, it's better. So we can use this, but let's make this row as a vertical and that one as a vertical, and let's merge those two rows. So from here we will make merge vertical rows, and from here let's select the origin plate and define the width of this one to be the delivered plate dimension, and let's split those plates like this and define the width for those plates to be the maximum width of the delivered plate dimension. Here let's repeat those again at the bottom here. So from here let's make it vertical orientation by the row, and from here vertical orientation. Okay, now we need to merge those, so let's select the above one and select merge vertical rows. Now they are vertical, so you have the ability to make this at the left. For example, if we wanted to make it at right like this, it's an option, so let's make it like this, but you can figure that the height of this plate is 3 meters by 5. So we need to make this one, let's split it, for example, split to right. Okay, and let's define this as like this, and for this one you can figure that the welding line here is not okay, it's too near to this one, so we have the ability to make it offset if we need to make it offset. So let's make it offset by 1 meter and click offset like this, and split this one to the left and define this to be 2 meters 0.4 like this, and make a split. You have many different options. For example, let's make it as a centered again and make it looks like the top one and split those like this. So you can make offset or make split, make it right plate or left plate. Okay, now we will change the longitudinal welding line orientation to make it 0 degree and save this one. Okay, let's update this again. Okay, and let's start creating the model. Click start to start creating the shells and compression ring and roof. Now the roof is complete, and let's add a cover to this roof. From here we will go back to the SEG, and from roof we will select element and select cover. Select cover from here, define the radial plate thickness, the overlap, and the length of this plate, which is dimensional. The longitudinal building line orientation, let's make it on 90 degree. Let's make it from 2 pieces, and let's add a cover from 6 mm and click save and start. Now we have this cover. Now let's add a spiral stair to this tank. So let's go back to SEG, and from here we will select the first can, and from elements we will add a spiral stair from external attachments, and you can figure how much elements you can add it to your model, like supports, nozzles, clean outdoors, weld outlet, stud outlet coupling, and the lifting lugs, the external connections like nameplate, supports, grounding, fireproofing, pipe support, all of that. From here we will add a spiral stair. And click add, and from here we will select a spiral stair from the tree, and let's define the dimensions of this spiral stair. Let's make that's the stair height without the platform grating, so it's from the stringer bottom to the stringer top point, so that's the straight height. So let's define it as like that. Stringer width, the contact angle, let's make it 25, and the orientation will be start from 25. Stair height at the end, which is that end right here. Okay, the cut at the beginning, the base from bottom, the width, and the direction on the clockwise or counterclockwise, that's the width thickness of the grating. So if you accumulate this value plus that value, it will give you the stair height from the top of grating. Okay, platform angle, let's make it 5 degrees, and to calculate this we have a tool here for the arc calculator. So if we inside the shell inside diameter or outside diameter, for example, and if we wanted to know if we have an arc length with 1 meter, what is the angle of included in this one, and if you delete this, for example, and if you would like to make the angle like this, and that's the arc length. Okay, so let's come back here and change the shell course thickness 14 and the wear plate thickness. Okay, those options, let's leave them, and from here we will make a radial cut to the first post. Okay, here those are a cut on the bottom and mid plates, so we'll make a cut to the end of this angle, and this spiral stair not connected to another platform at the beginning. Okay, so it's the first one, so it's not connected to another one at the beginning. And let's make the extension of the grating of the platform with ½ degree from here, and let's leave those values like this. The number of posts per stringer inside and outside, and let's make the bended rail at the end, which is this bend. Okay, and those values let's leave them as they are, and from here let's add the bracing supports, and let's define this. Like this, and this option for the close end for the platform, it's not close end because we have another spiral stair. Let's click save, and from here let's add another spiral stair, and let's make it the same dimension for spiral stair 1, but we will make some changes, like changing the start angle orientation for this one, the orientation. Here the orientation starts from 25, so it will be plus that one and the platform. So this one will be 55. Okay, and if we come back here, it's not cut it at the end, and this one is not radial end, and we will make this platform closed at the end. Okay, so those are the changes right here. And regarding to the extension at the end, let's make it 0 again, and it's connected to another platform, so we will select this checkbox. And regarding to the thickness, it will be 10 millimeters. Okay, and let's increase the clearance by this value. Okay, the difference between the difference between 14 and 10 is 4 millimeters. So let's make it like this. That's the clearance, and let's click save. And now let's click start assembly to start creating the 3D model of the spiral stairs. Now the spiral stair is ready, and you can check if you have any clashes. If we take a look here, this support is make a clash with this step, so we need to move it a little bit down or over. The same for this one. And if we take a look right here, right there, the welding lines, no clashes with the welding lines. So if you would like to make any modification, you will come back again to the spiral stair here and modify the options. Now let's add some nozzles to the roof. From here, let's add a nozzle with internal deep pipe. So from here, let's add a nozzle N1. And from N1, you can make it from pipe or from plate. Let's make it a nozzle from pipe, 8 inches with a reband, and let's define the reband width and thickness. The standard scalable. Okay, the offset from vessel center line, let's make it like this, and the orientation will be on 90 degree, and the projection from the outside, this projection, we let's make it with 2 meters for example, and the internal projection is 5 meters, and this one is temperature indicator for example. And let's click save, and let's define the welding styles. And for the external connection, we will add a flange. So from here we will add N1 flange, and this one will be ASME flange according to weld necklace face and the rating 8, and the schedule for this one, and click save. And for the internal, we will make a connection N1. And in this connection, we will make it split in flanges 8 inches, and let's make this one like this. And if you would like to add bolts to this one, we can make it. Let's add another pipe to this external connection, N1 B1, Okay, and let's make this pipe 8 inches, the same scalable, and the length is let's make it 5 meters for example, and click save, and let's click start assembly. Here, after adding this nozzle, let's take a section of the model. Sorry, from here, let's make a half section like this, and you can figure that that's the internal projection of the pipe, and that's the deep pipe with connected slip-on flanges. And by that way, you can add another attachments to this model. Okay, here, Part-1.